Alright, let's do this same problem a slightly different way. We will start by creating two areas up here. Call this 1 and call this one 2. What we will do is, yes, we're going to measure down from the same location to find y. We'll find the center of this one and the center of that one. This distance is 2, and this distance is 4, so it's not to scale. So this distance down to this one's centroid is 2, and then half of 2, or 4 total. This distance over here is 6. So down to here is 3. Now let's make a little table. And on this table, I'm going to put a section, just put it as S, and I'll have a 1, and I will have a 2, and that's all I have. I will have the area of each section. In this particular case, I'll have a Y bar for each section, and then I'll have area, or Y bar times area. So I'll try to make this a little bit reasonable. Okay, from here to here is 12 and 4, 16, so that means this is 16. And this distance is 12. So the area of section 1 is 16 by 6, or 96. The Y bar is straight up, it's 3. And the only reason that it's done this particular way is he's shown over here, it looks like the Y bar is measured down from the top right here. So you can go ahead and put in here the Y bar of 4. Now the area here is a 12 by 4, or 48. So now all I need to do is multiply 96 and 3. Gives me 288. Now I need to multiply 48 times 4, gives me 192. Now I have to recognize what I am actually doing. Now, a couple of things. One, I know I'm taking this out, or negating it from that. So in essence, what I'm doing, taking out, oops, not exactly where I wanted it to go. Taking this area out. So I'm subtracting off section 2. I'm adding section 1. So all I have to do is this, gives me 48. 288 minus 192 gives me 96. And we know that Y bar is equal to the sum of Y bar A over sum of area, even if there is a negative areas. So this means the total here would be 96 over 48, or 2 inches, just like the other problem. Now let's do the same thing for the moments, the second area moment. Now we have to remember I bar XX are here. Let's just go ahead and drop those in. Okay, so here's the portion out of the sheet that you'll be given on the test there. And what we really need to do is we need to make another table, and we'll make it kind of like this. I'll go ahead and put a line between this, indicating that I've finished one part and am starting on the second part. So on this table, I'll put the section as well. I've already figured this out, but I'll go ahead and put area there. So I can go ahead and do this. Plus 96 minus 48. Next thing I need to do is say the distance. This one needs to be looked at very carefully, or maybe I should put in the I first. I x about the centroid, which I'll leave a little space right there. Then I'll put the distance. Then I will go put the area times the distance squared. And finally, I will put I, and then I'll say I bar, I'll just say IX, I bar X plus A D squared. So I'll put the equation right there to remind us what we are doing. So now, for the first solid, what I'll do, I'll make it a little bigger so my writing will be smaller. So the 1/12, or here, I even can make the pen thinner. 1/12, the base. The base of section 1 is 16. So 16 times the height, which in that case was 6. 6 to the third will equal to. Now I'm going to go ahead and do the other one, which is 1/12. Now where I'm getting this from is this term right here. I'm basically finding the IX that way. 1/12, the base on it was 12, and the height was 4. 12 and 4 to the third equals 2. Take a quick look over here. I have to admit, this seems weird. Looks like it's 288, and this is 64. So let me see, was that correct? 16, 6 to the third, 12, I think it's right. Reason it seems strange to me is that this is 288, but I think this is just mere chance. Okay, here's the deal, the distance. This is very important to understand, and so I'm going to spend a few minutes on this. I have identified that the centroid of the composite is at 2 inches. Therefore, if I came across here and drew a straight line, it would be at, hang on, it would be, it would be at this point. Okay, that's not quite coming up, but this is supposed to be right here. This is the 2 inches. So I've identified this as 2 inches. For section 1, I need to take this centroid and move it that distance. For section 2, I need to take that centroid and move it that distance, which this is supposed to line up with the top of that. This, in fact, is 2 inches. This, in fact, is 1 inch. So the distance that I'm moving the first section is only 1 inch. The distance I'm moving the second section is 2 inches, and that comes from right there. So now I just multiply 1 times 96, that gives me 96. Multiply 2 times that, oh, that's 96, but I'm really not supposed to put any signs on here yet. I'm going to leave those off. And now what I need to do, I need to come in, I take this column, add them together, put them in here. So 288 and 96. 96 is 384, and 64 and 96 is equal to 160. We have to X this out here in this video. This is d squared times a, which is 48 times 4, not 48 times 2. So make sure you don't make that same mistake, or if you do make that mistake, go ahead and catch it. 48 times 4 pops out with 192. So hang on. 192. Pop this thing out. I'm not sure that that's going to be 192 plus 64. Why is it not? Oh, I'm putting it in the wrong thing. I'm putting it right here. I'm supposed to be putting it in MATLAB. Take that out. Here. Delete. Okay. No wonder it wouldn't come out of MATLAB. Okay. 192 plus 64 gives me 256. Now what I do is I didn't put in negative area, didn't put in negative here, but in fact, now I know this is, this is extracted out. So I take 384 and subtract out the 256, and I get back the 128, which is the same answer that showed up in the other problem. It's just, it had 3 sections, this has 2. So again, be careful of this. This is a mistake that I made. Make sure that you're squaring this as it gets transferred over, and squaring this, and it's slipped up simply because d squared is 1 is just a slip up. Don't get caught that same way, or if you do, just go ahead and fix it.